Hello friends, so this is our problem of the day 20 from GFG. So let's look at today's problem. Okay, so given a binary tree, the task is to find the maximum GCD of the siblings of this tree. You have to return the value of the node whose two immediate children has the maximum GCD. If there are multiple answers, return the one with maximum value. Okay, so let's understand the problem by an example. Okay, so this is a tree 4 5 2 3 1 6 12, right? So what we have to do for each node, for each node it has two children or one children or no children. Okay, so if it has only one children, then we don't have to calculate the GCD. Actually, GCD of what? Their children, because this node must have two children, right? Because GCD is greatest common divisor of two numbers. It is not the greatest common divisor of one number, right? So if it has only one children or it doesn't have any children at all, then we will do nothing. If it has only two, if the only case where we compute the GCD is when it has both the children. Okay, so suppose for this case it has no children, so we will not compute the GCD for this node, right? So the GCD for 4 GCD for 4 uh, GCD for 4 is actually the GCD for 5 and 2, which is 1. That is greatest common divisor of 5 and 2. For 2, the GCD will be calculated by GCD of 3 and 1. Okay, so for a node we calculate the GCD for its two children, as it has it is a binary node, it has only two children, right? So we calculate the binary GCD of two children. So if the node is 3, the GCD of 3, we will call it the GCD of this node actually, or the problem is asking for uh, the GCD of its children, right? So for 3, its answer will be 6 and 12. This is GCD of 6 and 12, right? So let us just compute the values and place in the node. So for 4, GCD of 5 and 2 is 1, right? 5 and 2 is 1. For 5, there is no children, it doesn't have any GCD. Okay, so it is empty. For 2, the GCD is the GCD of a node. Okay, so GCD of a node is the GCD of first children and second children. Okay, so for 2, the answer is the GCD of 3 and 1, which is 1. For 3, the answer is the GCD of 6 and 12, which is 6. For 1, the answer is empty. For 6, the answer is empty. For 12, the answer is empty, as they are all having no children either or one children. So these are the cases. So which one has the greater GCD? This node, right? So we'll return 3 here. Okay, so our answer is 3. We will not return the greatest or maximum GCD. We are not bothering about the maximum GCD. We are bothering about the node for which the maximum GCD comes, from which, or you can say from which the maximum GCD comes, right? So for this node, the GCD of 3 is the GCD of actually 6 and 12. Okay, so it is not right to say GCD of a node, right? So you can say that each node actually, what can I say, each node actually has an mapping to some value. For node is assigned to some value. 4 node is assigned to some value which is 1. Node 5 is assigned to some value which is empty. Node 2 is assigned to some value which is 1. Node 3 is assigned to some value which is 6. 6 is empty, 12 is empty, 1 is empty. So the value of GCD is saying it's not right. So you can say that so some node is assigned to some value which is GCD of its two child nodes. Okay. So what do we want to do? Very simple thing. We are going to calculate the GCDs, see how which one is containing the maximum GCD, return the node that contains the maximum GCD, like 3. Now suppose here is like this. Okay. So what will be then? Let's find this case, as it has the case where 3 has only one children. So for 4 the answer is actually 1. For 5 it is empty. For 2 it is 1. For 3 it is empty, because we are not going to compute the GCD in case of just one children or no children. So 3 has only one children, so we do not compute this thing. For 6 it's empty. For 1 it's empty. So the maximum is actually 1. Maximum GCD is 1. So what we will return? We will return 2. Okay. So let's check for this example. Okay. Our answer. Let's check the answer for this example. Just remove 12. The answer should be what? 2, I think. Okay. See, here the maximum GCD is 1 and the value is coming from 2 nodes. Here also I have a 1, here also I have a 1. So I have 2 answers. So what they are saying is that in case of multiple such nodes, return the maximum value. Okay. So from 2 and 4 we will return 4. Okay, so that's why the answer is showing 4 here. Okay, the answer is showing 4 here. Let's so this is the case. Suppose let's take another case. 1 2 3 6 9 36. Okay, so for this case the answer is 1. Here empty, here is 3, I think. Here is empty, here is empty, here is empty. So the answer should be, the maximum GCD is 3, right? And in coming from this node 3. So our value should be 3. This 3 is this one, and this 3 is the GCD, which is this one. Okay. So 1 2 3 null null 6 9 36. Right? 1 2 3 null null 6 9 36. So our answer should be 3, right? Okay, let's see. Yeah, so answer is 3. So we have understood it, right? So let's now see how to solve this problem. Okay, so here is suppose the tree 6 9, or it was what it was. Let's take this example. What was the example? 4 5 2 3 1 6 12. 4 5 2 4 5 2 3 1 6 12, right? So what we are going to do, we are going to traverse like this. In this type of questions, actually most of the medium or hard type questions, what we do is we compute something, and then we return something else. Okay, what we compute is the answer, and what we return is gonna help the answer to be computed. Okay. What we compute is our answer, the actual question, and what we return is gonna help to compute that this value. Okay. So here what we're gonna do, we'll traverse like this. Okay, and from here we will return 5. We will return 5. So for 5 it will return 5, that is its node's value. Okay, and at the same time I have two variables, uh, which is suppose no, which is suppose called GCD and val. Both are 0 at the beginning. So we traverse like this here. For 5 it has no children, right? So this value will not be updated. Okay, so we only return 5 here. Now it goes like this, then we got 6. Again it has no children, nothing will be updated. We'll return 6 here. We go like this, we return 12 here, as this also has no children. So it returns 6, it returns 12, right? Now 3 has 2 children. So what we will do is we will calculate the GCD of 3, or you can say for node 3 we will calculate the value GCD of 6 and 12, which is 6, right? And this is our previous GCD, which was 0. So which is the max, 6 or 0? Obviously 6. So we'll update this by 6 and we'll update this value by 3. As for 3 the GCD of 6 12, for 3 we'll compute the GCD of these two children, right? So this GCD is actually coming from this node. Okay. Actually the value is computed using these two numbers, but we are doing the values for a node, right? So each node is actually assigned to some value. So this is important. Okay, not the values of which we are computing the GCD. This node is important. So we'll update the value by 3. Okay, no problem. You understood. Now what? We'll go like this. This returns. Okay, so from here, so it computes the GCD. It becomes 6. We update 6 and 3. Now what it will return? It will return 3. Its value. So it's the Euler tree. Okay, so we are doing the operations in post order, right? So when the post order of 3 is executed, we will return 3 and update these values. Now for 1 it will return 1, right? So from here we got 3, from here we got 1. So for 2 the GCD of 3 and 1 will be computed, which is 1. So among 6 and 1, 6 is the greater, so we will not update it. Now it will go like this, and it will return 2. Now for 4, GCD of 5 and 2 will be computed, which is 1. So among 6 and 1, 6 is the bigger, so we will return 4, and the thing is done. So our final, what we will return is our final value, which is 3. Okay, not the GCD, we will return 3 here. Now let's take another example. This is not so satisfied. Let's check 1, 2, 3, 6, 9, 12, 4, and suppose 36. Okay, so what we are going to do, traverse like this, it returns 4, it returns 2 here, traverse like this. Okay, so traverse like this, it returns 12 here, returns 4 here. Now for 6 there are two children, so for 6 we'll compute the GCD for 12 and 4, which is 4. So here was our value, here was our GCD. So this is our GCD at the beginning, this is the latest GCD. So among these 4 is greater, so we'll update it by 4 and update our value by 6. As for 6 we got the GCD as 4. Now it will return 6 here. The loop goes like this. From here it will return 36. Okay, so no. It will go like this. For here there is one children, so we'll go like this, there's no problem. So we'll go like this, we'll return 36. Now here there is only one children, so we'll just return 9. I hope you understand. I'm doing this again. I am gonna do nothing. Okay, if only one children is there or there is no children, do nothing. I will do something when there is only two children. So for this case I will do something, for this case I will do something, for this case I will do something. Okay? So for 9, so the loop goes like this. It is working on post order, right? So post order 36 is returned. Now for 9 nothing is computed, 9 is returned. Okay. Now for 3 we'll compute the GCD of 6 and 9, which is 3. So 3 and 4 wins, so we will not update anything. Now from here 3 is returned. So for 1 GCD of 2 and 3 is computed, which is 1. So among 4 and 1, 4 wins, so we will not update it and return. So our value is 6, so our answer will be 6 in this case. Okay, now let's code, then we will try run this thing. That will be easy. So what we are going to do is we are going to create let's erase these things. Create a value 0 and GCD is also 0. Okay, now we are gonna create my new function. Where I will execute my recursion. So I am just returning value for each function. So the function actually returns the root's value. Okay, it's completely do nothing. Okay, the function do just return value of the root of the node, but we are gonna compute. So this is actually a trick to compute the things while traversing. So that's why we are just traversing normally, but we are gonna compute something while traversing. Okay, so this is a beautiful trick, you can say. Right? We got the left node value and right node value. This is nothing actually. So for root I got the left and right node values. So I am now gonna compute the GCD, my node GCD, okay, which is GCD of left value and right value, and I am gonna compute it if it has two children. Okay, so in the case of two children, it should not be empty. Okay, so what I want to say is that if this is the case, then I am gonna not compute, for this case I am gonna not compute the GCD. If it has only two children, then I am gonna compute the thing. So we'll come to that. Now let's leave that part. Suppose it has two children. So we compute it GCD. Then we are checking that if our GCD is greater than the, if our GCD is greater than this value, okay, then I am gonna update my GCD also as well as my value also as root value, okay. And or it may be happening that the GCD becomes same, okay. So suppose for this case, suppose the GCD is 1, and if I go like this, here also the GCD is 1, so I will return 3. The answer is, and there are many answers, 1 and 3, we will return 3, the maximum of these answers, okay. So if the GCD of a node is same as someone else, so we will return the maximum. So if my GCD is equal to some other GCD, so I will return, I'm not computing the value, I'm not gonna computing the GCD, actually GCD is same, right? So I'm gonna update the value. These are the values, right? These are the values are actually the node values, okay. So if this thing same, the GCD is same, I'm gonna take the maximum as my value. So values are the node values and GCDs are DCDs. So my value will be the maximum of what? Maximum of my previous value or my root dot data. So for suppose we are traversing like this, and after this the value will be what? 1, value will be 3 and GCD will be 1, right? So when we come to this point, so at this point this thing will be updated because we get a GCD of 1, so it was at the beginning 0, I get 1, so it will be updated to 1 and value will be 3. Now when I reach this point, I also get a GCD with my previous same GCD. I will check that this value or this value, which one is bigger. So if my previous value is bigger, I will keep it, otherwise update it by the 1, okay. So that is what I am doing, okay. So then just return root dot data. Now if our root is null, so if our root is null, then what we are going to do? If our root is null, so after here it becomes like this, right? It becomes like this and then come back to this because it is null. So for this case, as it has no children, we are going to not computing the GCD, right? So what we are going to return is actually a tricky part, okay. So we are going to return integer dot min value. Why? Because what can I say, that for 2 there is no GCD, right? So for 2 the GCD should not be updated, okay. So if I return the maximum minimum value, if it return the maximum minimum value, from right also it returns the maximum minimum value, then we will check here, we'll actually check here. Let me do the code first. If my left value or you can say here, if my left value is not equal to integer dot min value and right value is not equal to integer dot mean value, then we are going to compute this. Okay, so when we are going to compute the GCD, when each node have two children, then we are going to compute the GCD. In other cases, suppose it has only one children, okay, or it has no children. So for this case, from here it will return integer max, from here it will return integer max. So here, when after going like this it reaches here, we check that if the right value and left value for this node, this call be executed, right, left and right, so both are null, so they will return integer dot max. So if both are integer dot max, we are just returning the value, this value. Suppose this is 5, so we will return 5. We are not going to compute the GCD. So we are going to compute the GCD if they are not null. Okay, so for this case, so it returns 5, right? Now here this is not integer dot mean value, but after this null value will be called. From here it will return integer dot mean value also. So I am creating an AND operation here. So as 5 and this right node both are I mean this is integer dot mean value. So to execute the GCD, both has to be a value which is not integer dot mean value. But here one is integer dot mean value. Then we will not compute the GCD for this node, and it has only one children. Okay, I am telling this one second. Okay, I have two cases. Either there is one children like this, or no children. So for this case also it has no children, so it will return integer dot max. So when it will come here, it will see that there is all is integer dot max. So this condition is failed, So from here I will what actually do, I will actually else return root dot data, do nothing. Okay, so from here actually I will read this root dot data, that is this thing. Suppose it is 5, it will return 5. It check for left and right, both are integer dot value. This both condition is, so this condition failed, it will return 5. So for this the GCD is not computed as our target was. Now when it comes back here, from here it gets 5 from here, but for here it will get integer dot max. So left condition is satisfied, it is not equal to integer dot mean value, it is 5, but right condition is failed. So both has to be true, then we will go here. Now this condition fails because right one is null, so it will return integer to mean value. So we will not compute GCD. So what we will do, we will just return root dot data. If there was 5, it will return the 9 to its upper ancestors. Okay, so that's the thing. So if it's null, it will return integer dot max, right? So that is how I am gonna surviving myself by not computing the GCD. Okay, that is how I am surviving. That is the tricky part actually. Okay, I have to give some value. I cannot give a return 0 here because there must be a value. Suppose this node is, suppose what can I say? Suppose if I return 0 here, I have to give the condition as not equal to 0 and not equal to 0, right? Now suppose there is a node like this which has like this, two values are 0. Suppose this is the actual tree. And for this node, it gets both the value zeros. We are returning 0, right? So for 4 actually it will not be computed. Okay, so that's the thing, right? So it should be computed. and the answer should be 0, right? But it's not gonna compute. So for this case, will it run if I do this thing? Let me check once. Let me complete the code and I will check this by the giving 0 here. Okay. So our code is almost completed. Now let's return value here, and let's create a function for GCD. So creating a GCD is very easy. You can see YouTube for that. So if x is equal to 0 or my y is equal to 0, I am gonna returning 0. Otherwise I will do something else, checking this. If this is not equal to 0, then we compute remainder and place what? Place y in the place of x and remainder in the place of y, and I will return y. So suppose two numbers is 2 and 12. This is my x, this is my y. So what I am doing, I am computing x mod y. So it is 12 0 0, it is 2. So remainder is 2. Now x becomes what? This was our x. So x becomes now what? Y. That is, this becomes 12 and y becomes remainder, this 2. It becomes 2. Now we again do something. What? So actually take x and y as you. So here, if x is less than y or x is greater than y, doesn't matter, because in any case it will return to the thing where this one is smaller, this one is bigger. So suppose in this case I have taken this one is bigger, this one is smallest. So after that, x is 12, y is 2. So our thing will be like this: 2, we are dividing 12, 2 6 are 12. So our remainder becomes 0. So we will return what? So our remainder becomes 0, right? So we will return what? Y. So y is 2. So we are returning 2. So that is the thing, right? So we are, how we calculate GCD like this. Okay. Suppose I have 2 and 69. So what we do actually? 2 3s are 6, 2 4s are 8. I get 1 here. I will place the dividend in the place of, I will place the divider in the place of dividend. I will do something like this. When I get 0, I will stop and say that 1 is my GCD. So that is what I am doing here. Okay. GCD computing is very easy. Let's take 3 and 64. So 3 2s are 6, 3 1s are 3. So I will get 1. So I will 1 3 3 0. So 1 is the GCD. Okay. Let's take here 69. Okay, so let's take 6 and 9. 6 1 is 6. I get 3. Now 3 is the divider, 6 is the dividend. 3 2 is 6. I got 0. So 3 is the GCD. That is the thing actually. I am placing the dividend in the place of divider. I am placing the divider in the place of, I am placing the remainder actually, sorry, in the place of divider, and placing the divider in the place of dividend. Okay. So that is the thing I am doing. So I think everything is fine. Let's compile it. Shows an error. Very good. Why it's showing error? Else if my node GCD, that's right. Okay, so I have to define the my node GCD here as 0. Now this is working. Let's submit it. So I have submitted this once to check if it's alright. Okay. So yeah, it does it. A small span of time. Now see if we replace this by 0, what will happen? And we replace by 0. I was thinking that it's maybe right. Okay, so maybe that there is no wrong in it. Let's check. It's working. Let's give it a run. Okay, so it's working for 0. Okay. Now what it is working is that, suppose this is the case, then for this node it has two children. That's right. This is a node, it has two children nodes. These are not zeros. I am just circling it for understanding that this is a node. So for 0 and 0, the answer is actually nothing. Okay, the answer is actually 0. It has no common divisor, or you can say the divisor is 0 itself. So answer should be 0, right? So that is why it's working, because for this node I will do compute GCD if these two values are not 0. Okay, for this node also I am returning 0 here, 0 here. So the GCD of this node will also be not computed because these two values are 0. For this node also these two values are 0. As the base case we are returning 0, so it will not compute for the 0. And if this node has two children as 0, then also this will not be computed, which is all right. Okay, because it is 0. That is meaningless, right? That's the thing. That's why it's working. So it's fine. So this is the way of doing this problem. So I hope you like the problem. So if you like it, then please like, share and subscribe, and see you in the next video.